Hello guys, welcome to Learn Infinity. Today we'll discuss the objective mathematics questions on the matrix algebra. I'm starting this series to help you guys to prepare for the ESE, UPSC and other state level examinations. So in the next videos of this series, we'll see more about the other topics, and in this video we'll see only about the matrix algebra. And objective of this series, main objective is to help you guys in preparing for the upcoming competitive examinations, like we know OPSC-AEE exams, OPSC-AEE, OPSC-AEE electrical exam, especially electrical. My electrical friends, they are waiting for 1 year for this exam, so it should help. And secondly, to cover all the topics of engineering mathematics in brief, and this video series will give you quick revision about the mathematics, so you need not worry about mathematics too much. And finally, you will be able to learn basic things related to these topics. So let's start the first question. The eigenvalues of the matrix P 4, 5, 2, minus 5 are. So these are the options. So let's see, before solving this question, so first see what is the eigenvalue. What do you mean by eigenvalue? So first point is determinant of a minus lambda I equal to 0. So roots of this characteristics equation are eigenvalues. So eigenvalues are nothing but the roots of this characteristics equation given by a minus delta I, a minus lambda I determinant equal to 0. For example, a equal to 3, 2, 1, 2. Then if we calculate a minus lambda I, we know that I equal to identity matrix given by 1, 0, 0, 1. So lambda I equal to lambda 0, 0, lambda. So we can write like this: 3 minus lambda, 2, 1, 1, 2 minus lambda. So if we calculate determinant of this a minus lambda I, then it will come 3 minus lambda. We multiply these two terms and we take multiplication of these two terms. 3 minus lambda, 2 minus lambda, minus 1 into 2 equal to 0. So by simplifying, we get finally this quadratic equation. We can find by the formula the roots of characteristic equation by the formula, or we can simply find by factorization. So I have done here factorization. By factorization, we found lambda equal to 4 or 1. So the eigenvalues are 4 and 1. So eigenvalues, we can say eigenvalues of this matrix, a matrix 3, 2, 1, 2 are 4 or 1. These are very important properties related to the eigenvalues, which will help you to solve the numericals of the objective questions regarding this eigenvalue. So let's see. The first is the sum of eigenvalues equal to trace of the matrix. Trace of the matrix means along the diagonal elements, the sum of the diagonal elements. So here trace is equal to, you can say trace equal to 3 plus 2. 3 plus 2 equal to 5. Here we have written, we have found trace of a equal to 3 plus 2 equal to 5. So according to the property sum of eigenvalues, we have found previously that eigenvalues are 4 and 1. So 4 plus 1 equal to 5, and trace is also 5. So the property sum of eigenvalues equal to trace of the matrix. The second important property is the product of eigenvalues equal to determinant of the matrix. So as per the example, we have taken this matrix A equal to 3 2 1 2. If you find determinant of this matrix, 3 into 2 minus 1 into 2, it will become 6 minus 2 equal to 4. Determinant equal to 4. And product of eigenvalues we have already found. We have already found the eigenvalues which are 4 and 1. So product is 4. So these are the two important properties of eigenvalues. So coming to the solution of the first equation, the given P matrix is 4 5 2 minus 5. So as per the definition of eigenvalue, we can calculate the determinant of P minus lambda I, which should be equal to 0. So 4 minus lambda, 5, 2 minus 5 minus lambda, determinant equal to 0. So if we multiply these two terms, this will come like this, and by simplifying we finally will get this quadratic equation. Now factorizing, we'll get lambda equal to minus 6 and 5. Minus 6 and 5. So the eigenvalues are minus 6 and 5. Another way of doing this problem is by checking the options. You can we have the advantage in objective type questions are that we can check the options. If we don't know the formula, we can check the options. So by property 2 and property 3, but we have seen that trace of a matrix should be equal to sum of eigenvalues. So we have found the eigenvalues as minus 6, 5. So what is the trace? Trace equal to 4 minus 5. 4 minus 5 equal to 1. This is the trace. 4 minus 5 equal to 4 minus 5 equal to minus 1. This is the trace of the matrix. So if we see the options, what are the options? Only minus 7 and 8 and minus 6 and 5 satisfy the sum of the eigenvalues equal to minus 1. So other two options are eliminated. Now we'll see the third property. The third property says determinant of the matrix should be equal to the product of the eigenvalues. So if determinant, here you can calculate determinant equal to minus 30. So we can see among minus 7 and 8 and minus 6 and 5, whose product is minus 30. So minus 30 is product of minus 6 and 5. So you can see we can eliminate minus 7 and 8. So final answer will be minus 6 and 5. This is the way we do the question from eliminating the options, or you can calculate directly with the formula this. Coming to the next question, yes, here the answer will be B, minus 6 and 5. Coming to the next question, the larger of the two eigenvalues of the matrix is, here the matrix is given 4 5 2 1. So it is asking the larger eigenvalue. This matrix given is 4 5 2 1. It has two eigenvalues. So it is asking which is the larger one. These are the options 2 4 6 8. So here you can see here we have to find the eigenvalues of the matrix by the formula A minus lambda equal to 0. So 4 minus lambda 5, 2 1 minus lambda determinant equal to 0. By solving we get this quadratic equation, and by factorizing we get lambda equal to 6 and lambda equal to minus 1. So among 6 and minus 1, the larger value is 6. So answer is 6. So answer will be 6. Coming to the next question, At least one eigenvalue of a singular matrix is dash. At least one eigenvalue of a singular matrix is dash. These are the options: A positive, B 0, C negative, D imaginary. So at least one eigenvalue of a singular matrix, any singular matrix, any matrix that is singular. So we will see what is singular matrix. We will first see what is singular matrix, then we will solve this question. So what is singular matrix? Singular matrix is determinant of A equal to 0, so that A is called a singular matrix. The matrix whose determinant equal to 0 is called a singular matrix. Example, suppose we take the matrix A matrix as 3, 6, 1, 2, and we can calculate the determinant. 3 into 2, 6, 1 into 6, 6, 6 minus 6 equal to 0. So determinant equal to 0, so you can say this is the singular matrix. Similarly, if B is a matrix and determinant of B not equal to 0, suppose we take a matrix 1, 2, 3, 0. You can calculate determinant equal to 0 minus 6 equal to minus 6. So determinant is not equal to 0, so you can say this matrix is non-singular matrix. Here is written, if B is a matrix and determinant B not equal to 0, then B is called non-singular matrix. Next concept is how to identify a singular matrix. How to identify a singular matrix. So first calculate determinant. It is the simplest way. First calculate this determinant. If determinant equal to 0, it is a singular matrix. This is the first step, and the most basic fundamental step is calculate the determinant, and if the determinant is 0, then the matrix is singular. The next method says, in a square matrix, if each element of a row or column is 0, then the value of its determinant is 0. Suppose here it is given some 6 by 6 matrix where it has 36 elements. So 6 by, suppose here it is given 6 by 6 matrix, so here 36 elements, so it is cumbersome here. It is tough to calculate the determinant. So by observing, so how to tell if it is singular or not? Yes, we can tell. How we can observe any row. Here, for example, here it is given, here one column is 0. In a square matrix, if each element of a row or a column, here one column is 0, so you can say determinant equal to 0. Need not to find the determinant. We can simply see the matrix and say its determinant equal to 0, hence it is a singular matrix. Suppose another matrix given 2, 3, 6, 6, 7, 8, 0, 0, 0. Here the entire row equal to 0. So without finding out the determinant, we can say its determinant equal to 0, because this property says in a square matrix, if each element in a row or each element in a column is 0, each element should be 0, then its determinant value equal to 0, hence it is a singular matrix. Now the third formula says, in a square matrix, if two rows or columns are identical or proportional, the value of its determinant equal to 0. For example, suppose a matrix is given 2, 4, 2, 4. Without calculating its determinant value, you can say its determinant equal to 0, hence it is a singular matrix. This row is identical to this row, or you can say this column is proportional to this column. The property says in a square matrix, if two rows or columns are identical or proportional, the value of its determinant equal to 0. So next example, suppose a matrix is 2, 3, 5, 6, 9, 8, 6, 9, 8. Here two rows are identical. This row is identical, exactly same as this row. So you can say its determinant equal to 0. So hence it is a singular matrix. 5, 10, 10, 20. This column is proportional to this column. Hence you can say its determinant equal to 0 and it is a singular matrix. So these are the methods we can find which matrix is singular or non-singular. Now coming to the solution of the question. Singular matrix means determinant equal to 0. We have seen that determinant A equal to 0. Now we know that matrix determinant equal to product of its eigenvalues. We saw in eigenvalues properties that product of the eigenvalues should be equal to matrix determinant. So for singular matrix, if determinant equal to 0, so the product of its eigenvalues should be equal to 0. So if eigenvalues are x and y and xy equal to 0, either x or y is 0. So the answer will be 0. So here at least one eigenvalue of the singular matrix is 0. The answer is 0. Coming to the next question, it is very typical objective questions where the question looks bigger but the solution is you will get the answer in just a second, in just few seconds. So the question is, if at4 plus btq plus ct square plus dt plus e equal to t square plus 3t, t minus 1, t minus 3, t plus 1, 2 minus t, t minus 3, t minus 3, t plus 4, 3t. Here it is given the determinant value. This equation equal to this determinant value. Then calculate E. Then E equals to dash. These are the options: 33, 33 minus 39 minus 27. So 24. So how do you solve this? Put t equal to 0 on both sides of equation. Put t equal to 0 on both sides of equation. Put here t equal to 0. Put t equal to 0. Here 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 also t equal to 0. Everywhere put t equal to 0. If this equation is equal to determinant of this, so it should satisfy for every value of t. Equal to signs means for every value of t it should satisfy this equation. So if you put t equal to 0 everywhere, so it will come as E. Only the remaining part will be here left hand side E. And in the right hand side, if we put t equal to 0, these are the values we will get. So you can easily find out now determinant. So the determinant is coming minus 39. So what is the concept behind this question? Suppose a equation is given as like this. One equation, at square plus pt plus c equal to 5t plus 9. Then if it is asked what is c, you can put t equal to 0. Then here this term will cancel, this term will cancel, and this term will also cancel. So only remain will be c, and here 9. So c equal to 9. This is the concept. This is how we solve this type of problems. So the answer will be minus 39. Coming to the next question, it is asked what positive value of x makes the following pair of determinants equal. These are the two pairs of determinants. So it is asking if these two determinants are equal, then what is the value of x. So these are the options. Let's see the solution. Given this determinant equal to this, so we know how to find out the determinant. These two terms multiplication minus these two terms, and these two terms multiplication minus these two terms. So 2x square minus 15. should be equal to 32 minus 15. So finally we'll get x equal to 4 or minus 4. So as x is greater than 0 in question it is given the positive value of x. So if we take x greater than 0, so only remains is x equal to 4. So this is the answer. You can see the answer is B option 4. So what concept did we discuss today? We saw eigenvalues, how to find out the eigenvalues. How to find out the eigenvalues? We found A minus delta I. The determinant of A minus delta I A minus lambda I equal to 0. This is how we found the eigenvalues, and we saw two important properties, the trace property and the determinant property. What is the trace property? We saw the sum of the eigenvalue should be equal to the trace of the matrix, and the determinant of the matrix should be equal to the multiplication of eigenvalues. And we saw what is singular matrix, what is non-singular matrix. Singular matrix is determinant equal to 0, and how to identify the singular matrix we saw by simply observing how to find out the singular matrix, and we solved two numericals, determinant concept. So these are the concepts we discussed today. So that's for today. We'll see in the next video. Thank you.